Hello. Hello. Hi, Henry. Hi, Skylar.
Yeah.
Hi, Skylar. How was your test?
I managed to finish around 20 questions.
Oh, really? Okay. Did you check with the answer how much you get? How many you get?
Huh?
Did you check with the answer how many you get?
Um, it looks like I got around 13 plus maybe one or two because like from 19 to 20 I answered one or two of them, but I'm like I don't know what I don't remember what my answers were.
Oh, you said you get 13, right?
Well, yeah, like 13 are definitely right.
Oh, okay. Oh, okay.
I got 18 right.
You get 18 right. Cool. How many you get, Henry?
Um, I think 15.
15? Hello? 15? Okay, you think you get around 100. Around 100, anyway. Well, okay, I need to share my desktop. Let me share it. There are some, like, you see the first 7 problem, we don't want to talk about at all, right? 1, 2, 3, 4, 5, 6, 7 should be all okay, right? In the first 7, nothing should be, you should get nothing wrong, right?
Yeah.
Yeah, I'm fine on to 13.
You are to jump to 13?
Like 1 through 13, I'm all fine.
Oh, cool. Oh, I see. I see. So does anybody have problem with number 8? It's just Pythagorean theorem, right?
Yeah, essentially.
So is there no, any person has a problem with problem 9?
Their explanation, they had like a secondary explanation for number 9 that was interesting.
Yeah, very interesting, yes.
Yeah, their second one, like, order doesn't matter, so you can just simply do it like that, it's done. It was cool.
So do you think you can handle this? So let's make another problem. Say I just change the number every 2 to the 3. So ask you, what is the probability that Cherry gets 3 marbles of the same color? Okay. I give you a minute to deal with it.
Wait, so each person picks 3 marbles, right?
Yeah. So yeah, that's the question. So we send this to number 3 red ball, 3 green ball, 3 yellow ball. Then each person takes 3. Then also ask the chair to get the last 3 with the same color. Okay, you can send to me the answer by the chat. Okay. See, I have that thing. Huh. See, everybody we get different answer now. Very interesting. Wow, that's amazing. So everybody get different answer. Okay. Andy, what's your answer, Andy?
Well, I'm still doing it.
So I can tell so far you three so Henry, Skylar, William, you all have different answer, okay? So that's a little surprised me actually. So all right. Anyway, so let's look back again. And so let's forget about the website, the then explanation. So here's my explanation. So you have 2R, 2G, 2Y. So R, G, G, Y, Y. How many words you can make? You can make 6 factorial divided by 2 factorial divided by 90 of them. Okay. Among them, how many with end with the RR? Then you have 4 letters. Then G, G, Y, Y. Then how many words you can make essentially? So it's a 4 factorial divided by 2 factorial, 2 factorial is 6. So same will be 6 for the GG, 6 for the YY. So the answer will be 18 over 90. It's 1 over 15. Okay, so this is right? Okay, Andy got. Oh, okay, you have 4 different answers by the way. You said 4 different answers. Let's see the answer for this one. Okay, who got right? Same thing. So how many words you can make is 9 factorial divided by 3 factorial, 3 factorial. So what is the very answer? Going to be 3 times 6 factorial divided by 3 factorial, 3 factorial. Actually, I don't really know the answer. So let's let me get a pencil. So the answer is so 6 to 60. 6, 60, okay. Huh? No, maybe my actually 60 is not right. 6, 6 factor is 5, 4, and 3 factor. Yeah, that's right. So yeah, it's 60. 60 over 9 factorial. So 9 by 7, 8 by 7. Actually, I have the Photoshop here. Let's go together. We can go together. Huh? You cannot hear me? Yeah, I'm good. Who is silent? Cannot hear me? Oh, he's some. Oh, you can hear me now?
Yeah.
Okay. So it's 60 over. So what is 9 factorial divided by? So it would be 9. Wow. So divide by another 3 factorial, 3 factorial. Cancel that. Then 3, you got 3 here, you got 2 here. Okay. It should cancel for 9. So you got 3 times 8 times 7. 5 times 2. So cancel that. Cancel that, get 2. Cancel that, get 4. So Henry got right. So 128. Okay.
So isn't it, it doesn't matter if she picks them last, because if you leave 3, it's the same thing as if you just pick 3?
One more time.
So when you do it, can't you just do 1 times 2 over 8 times 1 over 7? Because if you leave 3 marbles for whatever her name is, if you leave 3 marbles for Cheryl, then that's like the same thing as if Cheryl just picked the 3 marbles in the first place.
Oh, okay. Yeah, that's the same. That's what you're doing. Yeah. Okay. So yes, 2 over 8. That's what you say, right? No.
Yeah, 2 over 8 times 1 over 7.
And 1 over 7. Yeah. Okay. That's good. That's the same as the answer. Oh yeah. Sure. That's good. Good too. Yes. The same as the second answer William just mentioned there, right? Same idea, right? Okay. So who changed the 2? Oh, I'm sorry. Skylar is right too. I'm so sorry, Skylar. Yeah, Skylar is right too. Oh, what's happening to you, William and Andy? Huh?
Oh,
Anyway, okay, let's do another one. Another one, similar one. So you can extend this problem to still 3 red ball, 3 green ball, 3 yellow ball. Also ask teacher to get the last 3, but it's 3 different color. So what is the same question? So the total outcome is still the same thing. So you just need to figure out how many. Everybody done? Huh. Why can't I get it back? Skylar, Henry. So William and didn't have the answer here, by the way. Okay. So probably right. Andy, waiting for you now. Are you confused with this? It's okay. We'll talk about it later today. The wording problem. I will show you the answer now. Okay, so total outcome is going to be 6 factorial divided by 2 factorial, 2 factorial. Actually, this will be 3 factorial in the other end. So the answer is same thing. We already have that thing. So just switch 60 to be 6 factorial divided by 2 factorial, 2 factorial times 6, which is, what do we have? That one was, so it's 6 times 5 times 3 times 6 divided by, I don't remember anymore, 3 times 9 times 8 times 7 times, I don't remember that thing now, okay. Okay, 3 times 8, sorry, there's no 9 anymore. Times 8 times 7, 5 times 2. So you cancel, 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 cancel. So you have a 3, then cancel. Let's cancel another one, 3, then cancel. Okay. Okay, 9 over 28. I think Bill Henry got right. Right? Henry got right.
Yeah, 1 times 6 over 8 times 3 over 7. It still works.
Oh, okay, good. Okay, that's good deal. So William and Andy had. So William, what's wrong with what did you do? What's wrong with it? Anyway, yeah, actually, the Henry just explained the things. So it's still good. That's a trick still working. Okay, actually in the past, there are similar problems like this. Say a box contains exactly 5 chips, 3 red, 2 white. Chips are randomly removed one time without the replacement until all the red chips are joined, or all the white chips are joined. What is the probability the last chip joined is white? This is the to sound first, MC12. It's problem number 11. It's around 10, okay? Around number 10, you have that kind of problem. So it's so basically this kind of thing is a wording problem. But you can use in the group trick like that thing. Let's do in that one. You don't look up, just do it to see what you got. To see if we can get right. Oh, okay. Let's check back. Skylight that. Okay. What? What? What happened? So it's the same question here. So we're waiting for Henry for the answer. Henry is still working? Huh? Are you there? Let's see what happened.
Yeah, I don't know the answer.
Yeah. Are you working on that thing or? Okay, this is all wording problem. You can do either way actually. You can using the trick you're just using the same thing. You can also use in the wording problem. Whatever. Give us an answer. Can I explain now or? Henry, do you still need more time?
Yeah, just 2 seconds.
Okay.
Okay, I have an answer.
So to white. So how many words you can make essentially? So the first appear there, then second appear there. So how many words you can make essentially? So I have 5 factorial divided by 2 factorial, 3 factorial. That's all. That's how many words, right? So how many end with W? So have W here, then you have R, W. Have 4 letters to make how many words you can make. I have 4 factorial divided by 3 factorial. That's all. So the answer is going to be, actually this is it's only 10, it's only 4. So the answer is 4 over 10, that's all. Right?
I thought the question was different.
Maybe actually. So let's check with.
No, I thought you said like once they draw and once like all of the reds or all of the whites are gone, then they stop. Not if once the whole thing is taken out.
Maybe you're right. Let me see. Okay, let's see. Maybe randomly remove the one at a time without replacement until all the red chips are joined. All the white chips are joined. Oh, yeah, only the part that the last chip is joined is white. Maybe different actually.
I think you have to not draw 3 red. So you draw 2 red and then 2 white. And then the combinations of those over the combinations of all of them.
That's actually depends on how do you, what the joy is. So chips are randomly removed at a time without replacement until, okay, so until the red is, okay, until the red is removed. Actually, yeah, I think you're probably right. I just didn't read the middle. So you actually totally 10 different things. You can really, let's just figure out one by one. So that's you can do first one is R, W, W, R, W, R, R. So R, W, then say R, W, W, R, W, W, R, W. So R, W, 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 R. Then you can have W, R, W, W, R, R, W, 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 R, W, W, R, W, R, W, R, W. Then I have only one more. What? W. I think we 1, 2, 3, 4, 5, 6, 7, 8, 9 already. Oh, okay. Now sorry, we just messed up. Not there's only 2 R. Only 2 W. We messed up here. We messed up from here actually. Okay, just redo it. Redo it. So 3 R and R, W, W, R. So we have R, W, R, R, W, R, W, R, W, R, W, R, messed up there. So then you have W, R, W, R, R, anyway, should have R, W, W, R, R, W, R, W, R, W, R, R. So we have, okay, those 10, totally 10 different things, right? So that one actually stops right there. So This one stops right there, right? Right? This one stops right there. This one stopped right there. This stopped right there. This one stopped right there. This one stopped right there. This one stopped right there. And this one never stopped. Oh, this one stopped right there. Right there, right? How many end with W? So this the one? This one? This one?
You missed one in the middle.
We missed one?
The RWW right after your second check.
Yeah. Oh, this one? Oh, so it's 3 over 5 then, huh? Right? Okay, it's 6 over 10 then. How do you, oh, okay. Then we can solve this problem. 3 over 10, 6 over 10. Let's check with the answer for it. Ready? I didn't pay attention on that one, so it's a little bit different though. $11. 2011? I didn't send 12 A or B, but 2001st. Okay. 12? No, 12. 11.
You said it was 10.
Oh, I'm say 10. Here we go. There you go. It's D. Okay. Oh, the second solution is very good. Okay, I didn't really pay attention to that one. Actually, I saw the different, similar program anyway. Okay, so there are always a counting problem like this, but for this one it's way easy because you only have the 10 cases. You can enumerate all the 10 cases like what I did. If you're really confused, you know. What happened? Can I get back now? Oh, okay. We can come to here and let me still. Let's see, do I have similar problem? Oh, okay. This is probably a similar problem. That one was not really similar problem. Saying maybe this is not either. The envelope contains 8 bills, 2 ones, 2 fives, 2 tens, 2 20s, 2 20s. 2 bills are joined at random without replacement. What is the problem? That actually is a little bit different. Anyway, so we're just saying around number 10, number 11, you see you always have the problem like this. A little bit counting with a little bit probability. So this is essentially the counting too. So you have 2, 2, 2, 2, 2. So you have 8 of them. 2 bills are joined at random. So totally you have how many you can join? How many outcomes for this one? Still actually,
Isn't it just 8 times 7 for total?
I'm asking you, everybody, how many total outcome do you have?
$56.
8 choose 2.
At choose 2, then at choose 2 is 28. So 56 or 28? What do you say, Skylar?
I say 24.
24?
Wait, no, never mind. Wait. 10.
What do you say, Andy?
Because
I think 56.
yeah, because I think order does matter. No, wait.
I'm saying 10 different total combinations. Like unique.
How many?
10.
10?
Yeah.
Oh my
I think it's 8 choose 2 because if you choose a $5 and then a $1, it's the same thing as a $1 and a $5.
Yeah. Yeah. Okay. Yeah. Right. Without replacement. Okay.
Okay. Huh. How will come that then goes away now? Okay. You know, this kind of things only you can. It's so little cases. If you really confuse it, then I just join like this. So you have 1 5 1 5. So I have 1 1 5 5 10 10 20 20. 1 1 5 5 10 10 20 20. So for 1, you can make 1 1 1, right? So 1. So 1 5 is 1 5, right? For 1 10 1 10. For 1 20 1 20, right?
Yeah.
So 5 1 what is 5 1? 5 1 you consider to be the same as 1 5?
I guess because we're looking for some. Like. They're probably the same.
Okay, so probably have 5 1, but they definitely have 5 5. Definitely have 5 10, and you have 5 20. So now 10. So 10 5 and 10 1. So 10 1, then 10 5 also appeared. Then have the 10 10. They have 10 and 20. So for 20, they have the 21s already appear here. Then 25 also appear here. So 2010s appear here too. So then 2020. So how many outcomes? If we don't think this one is, this one is, isn't, this one isn't, this one isn't, then we only have 1, 2, 3, 4. We have 10. Oh, this Skylar side? Skylar, are you saying 10 outcomes?
Yeah.
Oh, cool.
Are we asking for like sums or are we asking for like combination of bills?
Let's see. That's a really confusing actually. We spent too much time on this problem actually. I think consider 10 different outcomes, that's all. So only one is in the favor, so favorite. So it's the only one that 20, right? What else?
20 or more.
Yeah, 20 or more.
20 or more. Wow. This one is good too. This one is good too.
Anything with a 20 bill is good.
Yeah, it's only
But 1 in 20 works as well.
five of them. Okay. So there are two ways we can think about it. Okay. If we think about this one like a different thing, a different outcome, then you can have 16 of them. That would be totally different thing, right? So 16 of them, then 1, 2, 3, 4, 5, 6, 7, 8. So the answer is the same thing actually. So 1.5. So no matter what, the answer is 1.5. You see? It got to be that way. So you count the repeated or not count repeated, the same thing. So four of them. Actually, that's counted totally elementary counting. Oh, the answer is 1/2, I think. Let's check. 12B, 2005 12B. That's kind of elementary counting. Is 2005 12B. 11. Okay, so no matter, let's see how they count it. Oh, they count as this way too. So doing 1, 1, then they count. See, there are 3 ways to count it. So no matter what, you just get 1/2, right?
Yeah.
So if you have this kind of question, so you can just you know, if it's a big number, that's a problem. If it's a small number, so just enumerate it. It's confused. Okay. Anyway, so that number 10, we skipped number 9, I think. I don't remember why. So number 10 is this kind of problem. So probably easy for everybody, right?
Yeah.
So just for make sure you really understand it, it's difanting and misspelled it. So can you find like what is x for this equation? Nobody has it?
Can I see the question again?
Okay. Should not take that long. So if you take that long, means something is wrong. And maybe we didn't really learn how to solve it. So I can show you.
I don't know what is dipentene.
Yeah, it's just more variable than equations. Okay, that's dipentene equation. That's all. So if you have x plus y equals say you solve like x squared, x squared plus y squared equals 13. Then for the integer, you are usually talking about the integer solution, dipentene equation. Okay, dipentene. So talk about integer solution of this equation. You can see actually xy is going to be, plus 2 plus 3 plus 3 plus 2. That's all. That's all the solution. It has 4 solutions with it. Okay. So only have one equation, but you have 2 variables.
Wait. Can you say that again? Wait.
You only have one equation.
The analysis for the example.
You only have one equation. They have 2 variables. Okay, usually you have 2 equations and 2 variables. You can solve that for certain, right? You have 3 equations, 3 variables for certain. Then you have 1 equation, but more than 1 variable. Then those variables can change. If you solve the real numbers, this actually is going to be the whole circle is going to be the solution, right? The real number, the whole solution is going to be the circle. But for the integer solution, we're talking about, usually we only talk about integer solution. Dipentene equation only deal with integer solution. Am I confused you? Okay, anyway, so whatever you have for about this one, who only Henry has it? How do you solve it? So this is the way you solve it, okay? So xy. So if you try, you never get it right, okay? So you should not be trying. So you put 3x, xy together, they have x, and they have y plus 3. 57 minus 2y. Then you divide it, then you get 57 divided by 2 minus 2y divided by y by 3. So then you have put minus 2, then y plus 3 there, then minus 3 there. Okay? So y plus 3. So you get 57 there, then minus 2, then y plus 3, then plus 6. Then you get y plus 3. Then you get 63. Then minus, doesn't matter anymore, y plus 3. So then minus 2. Okay? That's the okay, that's an hour. Too big. Okay. So then you have to, this one has to be integer. So it's talking about integer. So y plus 3 can only be equals to 1. We're talking about positive integer even. 1 or 3 or 7 or 9 or 63. So you can have y can only be equals to this one not work. So y even 0 has to, so this one not work. So y equals 4 or 5 or 6 or 16. Then you get x equals to 4 minus 2, oh, sorry. So y equals 4, then you get x equals to, what is that? 7, then 9 minus 2 equals 7. This one actually is good. So y equals to 6, x is going to be equals to 7 minus 2 equals 5, so not good anymore. So this is the only solution. So x equals 4, y equals 7, okay? So this is the key, So you change to make this division, then goes to is y plus 3. Then you eventually get some numerical number over that thing. That whole thing has to be an integer. So y plus 3 has to be divided of 63. Is that good? Scala, did you get this problem?
Yeah, I got this problem.
Okay, good. Let's do we understand it, William?
Yeah.
Andy, good?
Yeah.
Okay, let's
Wait. There are two other solutions for this.
There are two?
Yeah, 5 and 6 and 1 and 18.
1 and 18?
And 5 and 6.
Really?
Yeah.
No, x has to be greater than y though.
Oh, wait, right, yeah, okay, never mind then.
Okay, let's do another one with this equation to see if you really understand it. So find x, y. This is sci-fi equation. Probably we still assume maybe still assume x greater than 0 at least for sure anyway. Oh. Anyway, as long as you find one solution, actually should find all the solutions. We assume x, y is greater than 0. Okay. What do you? Okay. So, think of something funny now. Skylar happened there.
What?
Okay. I cannot get the Photoshop back for some reason. Nothing is functioning now. Okay, Photoshop is back. Am I still sharing everything? Yeah, sharing. Still sharing. Okay. So that problem is you have 3x happened there. So 3x minus 4y, 2y squared, plus 4y, plus xy, 57. So, good. Can you find a bunch of solution? Okay. So you have x then y plus 3, then equals to y squared minus 4y plus 57. So you're doing the same thing, x will equal to y squared minus 4y plus 57. So y plus 3, that has to be an integer. So you can and still doing the same thing, 2 then y plus 3 square, actually 3 then minus 3 then square minus 4 then y plus 3 then minus 3 then plus 57 then divided by y plus 3. So you get 2 then y plus 3 minus 12 minus 4 then plus y plus 3 and 57 then still 63. So this one has to be the integer, so you can only have y plus 3 equals to 1, 3, 7, 9, 21, 63. So you have x equals 2. So 1, then get 2 minus 16 plus 1, which is minus 13, so that's not good. So 3, then I got 2, then times 3 minus 16 plus, actually, here is not 1 though. Actually, it's 63. You know, probably good.
Wait, isn't there a mistake? You can't just take the 3 out of the parentheses?
Take what? 3 out.
3 that was originally squared?
Here? Here? 2y plus 3 square, then divide by 1 plus 3, get 2y plus 3, right? So minus 6, then 12. So the y plus 3 is gone, so minus 12. So minus 4, then minus 4. All right? Then you have the plus 12. Oh, maybe you're right. It's plus 12. It's not 63. Not 63. Should be 18 plus 12, 30. Should be 87. Is that right?
Yeah.
Okay. Okay. The idea, anyway. So it should be 87. So look like, anyway. Let's just say everything. Okay, should be 87. So y plus 3 should be 87. Oh, should be 87. Huh, interesting. So it should be 1, could be 3. It's 29. 87. Now it's even better. Okay, only few solutions, okay? So you can have x equals to, so 1, then get 2 minus 16 plus 87. Actually, this is the solution. And 73. Okay. So 3, then x equals to 2 times 3 minus 16 plus 29, which is 19. So 319 is the solution. So 29, x equals to 2 times 29. Okay, actually y equals 3, that's not good, it's not good. So only 29, good. 29 minus 16 plus 3. Okay, this is the solution. Okay, this is the solution. X equals 20, y equals 26. So there's 2 solutions. I think this is our solution. So y equals to 26 and also 84. There are 2 solutions, okay? 26, 45, okay. Gotta get this one, okay. That's the whole point. So the whole idea is like this. So we didn't really talk about this, but you never get a chance to talk about this kind of equation. It's really lovely, this kind of equation. Okay? Okay, we spent too much time on this. But this is actually only the 10, number 10. You should be up to no problem doing the first 10, okay? There are a bunch of problems like this. Is there anybody has look at this one before? 2-digit integer that, like say, yeah, this is similar, but it's not same. Yeah, similar problem. Have you ever looked at this one before? Huh?
No, I don't think so.
Yeah, essentially this is the number theory. So actually this kind of problem really happen a lot. Say x, 2-digit number, you just write x as a, maybe something like a, b, exact statement, 10a plus b, okay? So something like 10a plus b, and y is obtained by reversing the digit. So y equals to 10b plus a. So x squared minus y squared, then just solve it. That's all. So get to be squared. So x squared minus y squared equals 10a plus b squared minus 10b plus a squared. So just expand it. So the cross term goes away. So I have 99a squared minus 99b squared. We have 99a squared minus b squared. So AB at most 0 to 9, so has to be a square. Has to be m squared. So actually this is like say 9 times 11 times a squared minus b squared equals to some square. So you have the a squared minus b squared must be equal to 11 times something, times some square. So now for you, easy to figure out. So a plus b, a minus b has to be something square. So a plus b has to be 11. There is no other choice. A plus b has to be 11. So a minus b has to be a square. So what is it? So 5, 6, that's actually 5, 6 is good. So 5, 6 is good, 4, 7 is not good, 3, 8 is not good, 2, 9 is not good. So it's only 1. So a equals 6, b equals 5. So you get everything. So you get everything. Then you calculate a plus b plus m. Okay, so got it?
Wouldn't 110 also work?
110? No, it's a digit. Digit. AB has to be digit.
Yeah. So wait. So but
10 is not digit anymore, okay?
oh,
Digit.
okay.
Digit is only from 0 to 9, okay? So actually, you know, this problem is problem 19. This is really, it should not be 19. That's a really trivial one, though. It's a basic number theory. Number theory just like say you just figure out which one divide which one has to be which one. So, all right, let's move on to the number 11. On sheet of paper, this one joins the two circle. Essentially, ask two circle have 5 different positions. In my geometry class, I had that figure, only 5 positions, okay? That's all. This one sent to a parabola, intersect the coordinate axis in exactly 4 points. And those 4 points are the vertices of height of area 12. Then figure out AB. This one should be fairly easy. If you know the definition of everything, should be fairly easy, right? Should we talk about it? Anybody? No? Then we skip it, okay? I think no. So this is really nothing. But this problem actually is well, it's not very strict. This problem, because anyway, if you're looking for the answer, let me talk about it. Is it so? Really mean the two parabola has to be like this. But actually didn't really saying this one has to be up. So we can anyway. Let's skip this variation thing. I think I don't know. I think never they have the ellipses. There though actually. Remember? Yeah, there was one problem with the ellipses. So let's look at it. So assume the ellipsis x squared over s squared plus y squared over b squared is 1. The left vertex, the vertex on the short axis, and the right focus also form a kite. Assume the area of this kite is half of the area of ellipsis. Find the eccentricity of this ellipsis. Okay, I give you like a minute.
How do you find the area of an ellipse?
Okay, who has it? The new version of that thing is weird. Okay, who has it?
How do you find the area of an ellipse?
Actually, it's pi AB. Pi AB. Actually, we learned that thing, but we didn't really prove that thing. So if you have, what happened? What happened here? The ellipses like this. So here's A, here's B. So the area is pi AB. Just like a pi r square, okay? If A equals to B, pi r square.
And like, what is the eccentricity? Is it like a percent?
I think the definition is the A over C over A. Then C over A, yeah. C over A. Yeah. C over A.
Can I see the question again?
Not coming now. So just forgot thing quickly. Right? Yeah, it's only way I remember is the ellipsis has eccentricity less than 1. The hyperbola the greater than 1. The parabola is equal to 1. Anyway, whatever. That's the way I remember it. So it should be C over A, always C over A. Anyway. Okay, who has it? Send to me anyway. Nobody sent to me yet. Nobody, huh? B over A. No, it should be C over A. Should be C over A. So the question asking is, what is C over A? Okay, that's the question we're asking. Should be C over A. I think we have the perfect ellipsis too. Where is it? Is that weird? I can't find that too. Anyway, that's okay. I enjoy it. Okay. Okay, let me explain. How about it? Looks like it's too hard. Who got it?
Pi minus 2.
Pi minus 2?
Yes.
Pi minus 2? Oh, okay.
Eccentricity. I don't know what that means, but okay.
Okay, so A over C over A is that thing you're looking for. Okay. So you have a focus here. So this is C. So this is B. So this is A. Here is length is A. So the kite. So what is What is the area of the kite?
The two diagonals multiplied together divided by 2.
It's b times a plus b, okay?
Yeah.
So what is this is the half of the whole area, which is pi AB, right?
Yeah.
We just cancel b, then get c over a equals pi over 2 minus 1. That's all.
Where did you get the minus 1?
A
Never mind.
A contribute 1. Okay, it's me, one more. So 1 plus c over a equal pi over 2. Okay, then back. So you're looking for c over a is pi over 2 minus 1. I think you forgot all the terminology. So confused which one is which one, which one is which one, right?
No, I just forgot to include a 2 in my answer. But
Huh?
I just forgot to take my answer and divide by 2. But
Okay. Actually, we have more. We're not working on that now. Okay, let's move to the number 14. I think everybody is good with this one, right? We're not talking about it at all, okay?
yeah.
Yeah.
So there's a similar problem with that. We are doing all good with that thing, actually. So, bunch of similar problem with logarithmic. So when you see 17, 22, even 12. Let's see. Okay, next one is the tetrahedron. Then ABCD has A equals 5, S equals 3, BC equals 4, BD equals 4, CD equals 3, CD equals. Ask what is the volume of the tetrahedron? So the
I
only
had trouble with this one.
huh?
I didn't get this one.
Yeah, actually this one is very easy. So the only problem with you is the imagination. You feel like it's the thing very hard. So so from today we'll talk about it. In the future, no matter when you are seeing this kind of problem, you should be able to solve it. Okay. So let's just say you have something like that. Something like that. So basically, you have a triangle there. Then you have something like let me just join this thing. So here, then you have here, then you join something like here. So this is the tetrahedron. So how do you calculate the volume? The volume is the area times 1/3 of the height. That's all. So if you have A, B, C, D here, so the volume is 1/3 of ABC, the area, times D. So how do you know one line is perpendicular to a plane? That's the only thing probably you are missing. So DE, if DE is parallel to the plane ABC, so if and only if DE is going to be perpendicular to everything, perpendicular to AB, how would that happen? Then DE is also is going to be perpendicular to AC. DE also is going to be perpendicular to BC. D is going to be perpendicular to any line inside of this plane, like this, like that, anything. So, so if you have anything, that's the definition of the. So one line is perpendicular to a plane if and only if it's perpendicular to every. So if this line is perpendicular to two of them, it's going to be perpendicular to the plane. Okay. So let's move on to this example to see how we solve it. So that one actually is an easy one because you can have AD equal AC equals to 3. So BD equals to BC equals to 4. So if you take E as the middle point of DC, then you have AE is the attitude of triangle ACD, BE is the attitude of triangle BCD. Is that clear?
Yeah.
It's the isosceles triangle. So if you make a BF, oh, we don't have it. If you make a BF, let me get this picture. We can talk about it. So if you join another line, BF, from here to here. So yeah, there is the explanation in the website. So join BF like that. Then the thing is, you can claim BF is the height from B to the bottom ACD, so to the plane. So BF is going to be perpendicular to the plane ACD. Why? Let's see. Because we explained that in one thing already. Because CD is perpendicular to BE, right? Do we see it? Can you see it? CD is perpendicular to BE, right? Because the triangle BCD, BE is the attitude, okay? Okay? So CD, same reason, so CD is also perpendicular to AE, right? Because triangle ACD is an isosceles triangle, then AE is the attitude, right? You got it? Yeah, you can text me if you think you. Okay, so CD is going to be perpendicular the plane ABE, right? According to my explanation a moment ago. So you have CD is going to be perpendicular to any line inside of the plane ABE. So especially C is going to be perpendicular to BF. Okay? So BF, according to that our construction, BF is perpendicular to AE. Now BF is perpendicular to CD. We just said about it. So you imply BF is going to be perpendicular to the AE and the CD, the plane, which is ACD plane. Okay? That's the whole point. Clear or not? So this is everything we want to say is this thing. So BF is perpendicular to the ACD plane. So we get the volume is equals to 1/3 of ACD times BF. Okay? So it's 1/3 of ACD, which is AE, times, half of AE, times CD, times the BF. So equals to 1/6. That's still 1/3. Let's move to here. So equals to 1/3 times 1/2 AEBF then times CD. Okay, that's it. So what is the AEBF? This is the volume of area of AB and CD. Okay. So CD is known. CD equals to something. 12/5 square root 2. Okay. Now we need to calculate the triangle ABE. AB is known. Then BE is almost known. B equals to square root of BC. BC, which is 4. Then here is 6/5 square root 2. So B is 16 minus 5/6 square times 2. Whatever it is. So it's you can get 4 out. They have 4 minus 5, 2 times 18. They have that's square 18. So have 2 times 5, 100. 82. That's weird. This might not be right. So 16. What is it? What is the CE? Oh, B. Yeah, what is B? Paper. 16 minus 25, 36, and 2. They have 4, they have 4, 2, they have 4 minus 25, 18. Okay, it's right. So 182. Oh, it's 82? I remember the answer to be different. Anyway, B is 82. Oh, okay, so you get AE. Same thing you get the square root of 9 minus 5/6 square times 2. You get 3 times. Okay, it's divided by 5. So that looks like pretty messy. So 25 minus 17. Wow. 5. Okay. So this method looks like actually the book. The book. Actually, they did the similar thing. How could they get good number? So the whole idea is you have AB, have BE, have AE. Then you are using Heron formula, you can get ABE. But for this one, maybe my calculation is wrong somewhere. So after you get ABE, then you get the volume, okay? So because CD is known. So my calculation could be wrong for something. This is 3, this is 4, this is a 6 over 5 square root of 2. 6 over 5 square root of 2. Why we didn't get a good number? Anybody know? I think they make up to be good number. Did I make something wrong here, guys? Okay.
What is this part and then this part? How do you get that? Like how did you get from there to there?
Hold on 1 second. Let me close something. Obviously something wrong here. Oh, can you see my screen well? Something blocked it, right?
Yeah, there's this go to it error thing blocking.
Okay, now I'll close it. Okay, say it one more time, Henry.
So how did you get from the do you see the arrow, the first arrow that you drew?
Okay. Okay. So so far here is the okay. Here.
Yeah.
So I just rewrite everything. So AE is AE here. So BF is BF here. CD is CD here. Okay?
Oh yeah.
1/3 and 1/2. 1/3 and 1/2. Still there, right? And just change the order CD and BF. Just switch the order. Right?
Okay.
Then switch the order, the magic thing happens is AE times BF is the area of triangle divided by 2 is area of triangle ABE. Okay?
Okay.
The whole thing calculates the ABE, the volume, the area actually is using Heron formula because you can find the BE by this Pythagorean theorem using the CE because here is the perpendicular, okay? Here's the perpendicular, right? Right? So here is the perpendicular too. So using Pythagorean theorem, find BE, then find AE. Then you can figure out the area of ABE. Then figure out ABE, then using the formula, you can figure out the volume. Are you with me? Right?
Yeah, good.
I think I figure out this one is wrong. How could figure out B? B is a pretty bad number here. 2 square root of 82 divided by 5. Then A is square root of 17 divided by 5. So, you know, this is the one side, this is the one side, this is the one side. Those three get using Heron formula, get a good number. I don't know. Let's see how they're doing. Let's see. Let's see here. Why we did it wrong? That's weird, huh? Which problem is it? 16. It's only 16. It's supposed to not be that hard. So then AE and BE. AE, actually we did it wrong anyway. AE is 163. 353, 328, 328. So it looks like a B. Oh, okay. Then call AB different. Okay, actually, it could be right though. Yeah, I think we did it right though. Okay, then that will be. I cannot get it back. Okay, actually, we did probably right. 53, 153. Right by that. Yeah, actually, this is right. Then yes, both of them are right. Okay, but just because then calculate the area. Okay. Anyway, the Heron formula actually cancel out the square. So you get this thing equals to 3 times square root of 2. So 3 times square root of 2. So then get good answer with it. See here. So we did it right. But the Heron formula is very, very, very ugly for that thing. Okay. All right. You're probably still confused. The second one is a pretty good answer, but it depends on the 3, 4, 5, the right triangle. So I don't want to depend on this. So, so I talking about the general situation. You can have saying, I think hydrogen like this. Actually, it doesn't have to be isosceles at all. So this one just makes things a little easier. If your triangle have AB equals C, then you have AC equals to AD equals to B, then have the BD equals to BC equals to A, then have CD equals to something like twice of D. Then you can make a similar thing. So make E the middle point, then calculate BE, calculate AE, then calculate using then using the formula again, you get the same thing. Okay, so triangle AB, then 3D, 2D divided by 2. Okay, this is very complicated to look like because this step here, saying that thing, it's pretty complicated. You probably need like obviously performing huge amount of computation. Yes, so this is true. Okay, it's going to be a huge computation with that thing. This probably like take you 10 to 20 minutes to really solve this problem, believe it or not. But the second one is really, really good one. So I can talk about it. Let's move forward a little bit. Then we come back to talk about this second solution if possible, okay? Actually, I did make another example with it. Say, yeah, that's where, okay. Using Heron formula. So I did make an example with this. Actually, it's a good number with it. So A equals 2473, CD equals 248, B equals 50, C equals 15. It's a good number. I calculated. Same situation like this. A, B, C, D. Let's move forward, then come back. If you have time, then calculate this one, okay? We only on 16, surprisingly. Okay, I think probably we can finish that one. So 8 people are sitting around the circular table, holding a fair coin. All 8 people flip the coins, and those who flip heads stand a while and flip the tails remain seated. What is the probability that no 2 adjacent people will stand? That one actually my solution to the it's exactly almost exactly as the book the website has. I think somebody disappeared. No? What happened? So so you have this is a case work. This is a pretty easy thing actually. Should we talk about it? No. Very easy thing. So case work. We have case 0. So essentially just have 8 places. So either saying places 0 or 1, 0 or 1, you know, head or tail, head down. So after you, like, what is the probability to just no two adjacent place is 0. So how many outcome? Every place has 2, so we have 2 to the 8, which is 256 outcome. So we need to figure out how many, how many non-adjacent zeros. So case 1, you just have 1 0. 1 0 means head up maybe, and maybe you sit to stand. So this is only 8 cases. Actually, there's another case, case 0. Say no 0, okay? No 0, they have 1 case. So case 1 has 1 0, they have 8 case, and they have case 2, they have the 2 0, they have case 3, as 3 0. As case 4, 4 zeros. I think William disconnected. Maybe it's too late.
He said he couldn't hear you.
Huh?
He said he couldn't hear you, so he's reconnecting to see if he can like try to fix it.
Okay. So 2 0. 2 0. Then you can have to using the CP complementary principle to counting, because you can say 2 0. Essentially, say 8 position, choose 2. That's all the possibility. Then you can say 0 here, 0 here, there's 1, 0 here, 0 here is 1. Then it's 8 of them removed. So this is complementary principle. You calculate how many cases with 2 0 adjacent to each other. Then remove them from the whole cases. Then 4 zeros, only 2 cases, and 0, 0, 0, 0. All 0, 0, 0, 0. So only 2 cases. So 4 zeros, only 2 cases. 3 zeros. How do you count how many? 3 zeros. That's actually, you have to use, you have 8 positions. How many cases? This is like say, this one you have to use in the balls, in the box situation. This is a little bit complicated. So how do you say it? You put so you put 0 here as the divider actually. So 0 as divider, then box is here, box is here, 0 divider, x box is here, 0 divider, have the 4 boxes. Then you have how many? 3 zeros, then have 5 ones. So 5 ones, then 3 zeros, 5 ones, then put 1 here, then 1 here. You know, we can just circle that box to be that box connect. So it's a circle, so it's a 3 box. It's like 3 boxes, so we put 1 here. So 3 boxes, 3 3 boxes. So you have 2 ones. So it's like 2 ones put into 3 boxes. How many ways you have it? You got it? It's a pretty pretty complicated situation. So you have so what is the formula for 2 ones? 2 ones put in the 3 boxes. How many ways we can do it?
5 choose 2. Wait, I mean 4 choose 2.
4 choose 2, yeah.
Oh.
So we have 4 choose 2. 3 zeros. Let's see. So this one you have then when you have 3 zeros, you only have 6 cases, huh? My original is it's not like this. So 9, 15, 37, 20, 37. That's what the answer was there. Actually, it was 40. This one should be 16 actually. That's key. 3 zeros. In the afternoon, I still counted exactly right. Now, actually. So the answer actually was 47, I remember. So 20, 30, 16. I don't have it. I don't have it anymore. Look at.
I think it has something to do, like you need to do times 8 or something. 6 times 8.
Just a second. Actually, in the I have a better solution with it. This solution I even don't, I don't know. So hold on 1 second. Let me get my paper with it. Take it fully. Okay. Okay, here's the solution with 3 zeros. So I see. I didn't really calculate that way. So actually it was something else. Okay, 3 cat. That's actually it's fairly easy. You don't really need to do that way. So you still so you still have the 2 cases. Okay, still have the 2 cases. So 3 zeros. So have 2 cases. One case is if you have like 2 zeros next to each other. So 3 zeros like this, then you have 8 cases, right? 8 situations. So 0, 0, 0, just 0, 0, 0. Then you have 0, 0, 0, 0, 0, 0, then 0, 0, 0. So we have 2 cases. So the second case is saying if you have the 0, 0 connect to each other, then the other 0 is just not connect with it. With it, then you totally have 32 cases because you have 8 of this. Every 8 of this you have 0, 0. Then you only have the other like 4 players can choose the other 0. So we have 32 cases with 0, 0, 0, 0, 1, 1. Somewhere else has 0. So I have 32 cases. So totally at 0 you have 8 choose 3 minus 8 minus 32, which is the 16 cases. So totally here we have 16 cases. So add up together is 47 cases. I even forgot what it is. So when you need to concentrate to do that thing. Okay, let's end up today with one more problem with your thinking about it. So then, unfortunately, we didn't really finish it. So, so 10 people are sitting around the circular table, each holding a fair coin, or 8 people playing coins. Okay, no, okay, it's just 10 things. There's still a bunch of variation with it. Okay, everybody look at this one, then going back home. So we end up with this one, then maybe continue talk about next time. He's already finished. I think William also disappeared for some reason. So this is the MC12B12. The parking lot has 16 spots, 12 cars arrive, then requires one parking space, and then drivers choose space at random from among the available space. EM then arrives for SUV, which requires 2 spaces at the jump space. What is the probability that she is able to park? Let's talk about next time. Talk about from this problem. Done. Okay. See you next time.
Okay. Bye.
Bye bye.
Bye.